All right, we're talking about special right triangles this morning. We just finished talking about the algebra piece, and we're getting ready to talk about the 45-45-90 triangle theorem. So I hope the other day in your homework, in your investigations worksheet that you had that looked like this, you did the Pythagorean theorem and you saw that every time you got side, side, side root 2. And side, side, the two sides were the same amount, and your hypotenuse always came out to be that same number, square root 2. This one came out to be 5 square root 2. And so the pattern we would say then is some number x, and then that same number x always times the square root of 2. And this happens anytime your triangle is isosceles, two sides are the same, and you have a right angle. Or, in other words, when you have two 45-degree angles and a 90-degree angle, then this happens. Alright, so back to the notes. The formula is that you have some number x, here, I think it'll make more sense if we call it n, some number n, and some number n square root 2. I think Miss Stoltz may have called it a. It doesn't matter what letter that is, just that it follows the pattern. Alright, where the hypotenuse is always whatever the leg is times the square root of 2. So let's try this out in example 1. Find the value of each variable. If your answer is not an integer, leave it in simplest radical form. So we're going to find the variable and then do our factor tree if we have to. Okay, so here we go. Our 8 is on the leg, so this would be 8, and x would be 8 square root 2 because it's on the hypotenuse. This is 3 and 3. How did you know that, Miss Benton? Well, because I know my hypotenuse is always some number square root 2, so n square root 2. So in this case, my n, both my sides, or x, whatever, would be 3. What about in part C, though? You have two sides that are both 7 square root 2. We know that these would be my n, and my hypotenuse should be n square root 2. So in this case, 7 square root 2 is just that yellow part there, n. So we have, 7 square root 2 is what we're going to replace here for n. But then you also had a square root 2 that was already there, right? So I'm replacing n with square root 2, and I had a square root 2 already there. Well, I know square root 2 times square root 2 is square root 4. Ooh, and then I know that the square root of 4 is just 2. So 7 times 2, or 14, is what you get. So kind of weird when you have a radical on the side, but the pattern still applies. So I'm going to let you pause the video and work the 3 U tries. Okay, here we go. On you tried D, hopefully you said 6, 6, and 6 square root 2 for x. I hope on part E you figured out that the two sides were both 7 since the hypotenuse was 7 square root 2. And on part F, 3 square root 2, this side would also be 3 square root 2. X, the hypotenuse, is going to be 3 square root 2 square root 2. Why is that? Again, if this is my side length n, then my hypotenuse is n square root 2. So when I replace n with what n is equal to, n is 3 square root 2, right? And then I already had the square root 2 that was there. So we get 3 square root 4. We know that the square root of 4 is 2. So 6 is our final answer.